Triple your pattern making in 3 easy steps. Step 1 is scan, step 2, convert to CAD, and step 3, flatten 3D to 2D. This is ExactFlat Scan-to-Pattern, and we'll show you how. The Convert to CAD workflow has 5 steps. First, you assess and plan by reviewing your scan, defining your objectives, and planning the steps you're going to take. Next, you'll align your scan to the origin. Following that, you'll edit your geometry by filling in holes, trimming and smoothing edges, and defeaturing your scan. Next, you'll prepare your pattern segments by creating planes, cutting your mesh, and combining your mesh together. And finally, you'll save your model. This is how our part looked originally. You can see the obvious characteristics such as the weld lines, the plates, the handles, and the assembly at the top. This is how our part looked after scanning, and those features have certainly been captured by the scanner. You can see the handles, you can see the weld lines, you can see the scan has some holes in it. There's the little relief valve in the center. There's some more of the weld lines. And of course, the assembly down at the bottom just looks like a jagged edge, not very clean at all. So what we have to do is we have to clean up this scan and prepare it for flattening. And the process is pretty simple, but here's what it's supposed to look like at the end. Now you note a couple of things that's going on here. First, there are very smooth edges. We have defeatured all of the bumpy bits here that we wanted to eliminate. Secondly, we've taken away artifacts of the scan that we don't need, like the handles, the top assembly, the stem at the top, the bottom. And you can see the hole there on the right-hand side. That hole was where the relief stem or the relief valve was. The other thing you can see here is the plane. The plane is where you're going to cut your pattern pieces. That was part of our design process. So this is just a quick snapshot of before and after. And we arrived at this snapshot by working through the steps on the right-hand side. We first review the scan, we assess and plan it, we align it to the origin, we edit the geometry by filling in the holes, trimming and smoothing the edges and defeaturing, and then lastly preparing the pattern segments and saving the model. But this gives you a sense of where our final goal is to be for this video. Okay, before we begin our workflow steps today, I'm going to ask our application engineer, Luke Naransky, to just cover some of the basic elements of the VX model interface and how to use some of the features that will be very helpful in our Convert to CAD process as it relates to creating pattern pieces. I'm going to hand the microphone over to Luke now. Luke, take it away.
So just a bit of recap on VX model. We can very easily orbit around the model just by using the left mouse button. So we click, that activates the orbit tool, and we can orbit the camera around the model. We can pan the camera using the middle mouse button. So we just click the middle mouse button, and now we can pan the camera around the object. If we right click on the object, we get a context menu. A couple of useful items in here are a center viewpoint and a set rotation center. This allows you to very easily pick a location on the model, and now I'm orbiting around that location there. So it's more useful when we zoom in on an object, so I can set rotation right here, and now zoomed in I can very easily orbit around that one particular location there. So not as useful when we're zoomed all the way out, but it's more useful when we're zoomed all the way in, trying to get a very good detailed look at something. You can set the rotation center, and then you can orbit and rotate around that. As for the actual interface of a VX model, we've got our viewing triad down here, so we can click any of the faces to snap to that view. We can click the arrows to translate our view so it's orthogonal to that axis. We've got our different shortcuts down here for X, Y, Z, and that will help us adjust the viewing planes. Right now we're looking at the navigation tree, so we've got our single mesh here. We haven't added any additional entities or split this mesh or anything, so right now we're only seeing the mesh. If we click the eyeballs beside anything, we can turn on or off display of those items and entities. So as we start adding more entities and stuff, that becomes useful. Right at the very bottom here, we can change from navigation view to display view, and this is where we can adjust the display parameters. So probably the most important or most useful control here would be the shading mode. So right now we're viewing triangles. You can view triangle with wireframe. That allows you to see the mesh. So right now we've got quite a few triangles here. This is useful for detail work, but if you're just working on the mesh, usually it's better just to stick with triangles. That way you get a nice smooth shaded view. It allows you to see the relief of the model a lot better, such as all the weld seams here. And I don't know if there's a label or tin plate on the side here, but we can definitely see the outline of that here as well. So later on we will be defeaturing this to remove that detail. So there's a few options here, but these are probably the most useful ones. So you can adjust any of these however you want. You can adjust the clipping plane or the glossiness of the material. You can turn all this on or off and adjust it however you want, but these are by far the most useful ones down here. So we're now into VX model, and we can see the gas tank in front of us. So we've got a mesh here, and just quickly looking at the mesh, we've got some holes here, we've got some valves, we've got a bunch of weld lines here. We've got a couple of brackets here, mounting brackets, two of them at different angles. And we've got a base plate down here with some kind of structure to it. I'm not sure if this is piping or valving or just artifacts from the pedestal that this was scanned on. I'm not sure. And we also have another pipe up here, again with holes in it. So what we're going to have to do is we're first going to have to patch these holes in the main body here. These are the most important ones. We need to preserve this surface so we can flatten it. We need to preserve the location of this valve here. This looks like some kind of bleed valve. And we need to preserve the location of these anchors here. These are the most important ones, and then the piping at the top and the bottom. Because we've lost quite a bit of the resolution of the bottom, we're probably going to end up splitting this off, and for the purpose of this video, we will just assume that it's a closed bottom. For your application though, when you're scanning your own object, you just want to make sure that you have sufficient access to all areas of the model that need to be scanned. That way when you're scanning, you're capturing the true surface of the entire part. For this one here, we just didn't capture enough data on the bottom, so for the purposes of this video, we're just going to cut it off, and we're not going to consider it for flattening. We'll just have a big hole here where the cover will fit around. For the top here, we will do the scan. We're going to cut the top off. We're just going to assume that the cover just comes up to this pipe here, and this protruding part is not part of the cover. And we can do the same thing for this here. We will leave a hole in the cover so there is access to this plug. That way we're not covering it up. And then what we'll do is we will have, we'll do this as a two-piece cover. One piece will fit up here, and then another piece will fit down here. That way we have full coverage around the brackets. So your own design may vary. You may do this as a single piece, a two-piece, or multi-piece. It really doesn't matter. The purpose of this video is primarily to show you how to take scan data such as this. We're going to show you how to use VX elements, specifically VX model, to prepare to fill in these holes, to prepare the model, and bring it into Rhino ultimately for use with ExactFlat to produce flat patterns. Okay, so we're going to start with this object here. We can see our triad over here. This is the origin of the model, and we can see that the model isn't really aligned in any particularly useful orientation. So probably the first thing we're going to do with this model is we're going to try to align it so it aligns with our origin, our axes. That way, when we start working with this with ExactFlat, specifically bringing it to Rhino, it's going to be easier to rotate it around and work with the model. It's also going to make it a lot easier for us to start trimming the top and bottom of the model if they are aligned to an axis or a plane. So there's a couple different ways to do this. By far the easiest one would be to create a cylinder around this. So then what we can do is we can rotate the cylinder axis so it is parallel to one of the axes down here. So probably the z-axis would be the best one to rotate it to. So the way we're going to create the cylinder is when we look at the cylinder tool up here, we're going to add a cylinder entity. There's a number of different ways we can build the cylinder. We can build it based off of triangle selection, numerical value, or vertex selection. So we're going to take advantage of the triangle selection, and we're especially going to take advantage of the construction of this tank here. It's already cylindrical, so we can best fit a cylinder based off of the main body. So the best way to do that would be to select the triangles of the main body. Fortunately, VX model has a number of selection methods, starting from the top. By the way, if you don't see this view here, there are two different modes for viewing your selection tools. The default is compact mode, and with this mode you don't really see all those tools. You have to click the down arrow here to get those. I like to click this down arrow and change our viewing mode to expanded mode. That way I now have access to all of the selection tools here. As we choose different selection tools, we're going to get different options appearing here as well, but we'll get to that a little later. So in terms of selection tools, there's basic rectangle selection. Because left mouse is orbit, you have to hold control on the keyboard, and once you hold control, you now have your selection tools, and we can select any number of the triangles that we want here. And then we can just press Control D to unselect the triangles, or we can just do the select none option here, clear selection. We also have our cylinder mode open right now, so I'm going to close that for now. But so we have rectangle selection, we have freeform selection. This just allows you to draw any kind of shape, and it's going to select whatever's in that shape. There's brush selection, so this is similar to the paintbrush in Photoshop or Illustrator. You have got a brush here, you can adjust the brush size with your mouse wheel to whatever you want, or you can change the slider here. There's select connected, so if I select connected here, it's going to select all adjacent connected triangles. This is a very useful method for eliminating floating islands or disjoint meshes. You can select connected for the main body, and then you can invert your selection, and whatever's left, I've only got a few selected here. There's one right there. You can just delete those, and in fact I'll do that right now. We'll delete that because we don't need it. Excuse me. There's a sudden change, so this is useful for selecting triangles that have a sudden change in curvature on the mesh, and depending on your settings here, it may or may not work the way you expect it to do. But this isn't the one we want right now. We're looking for a similar curvature. This is the one that we really want right here. And so what we can do is we can select this here, and it's going to select all the triangles with a similar curvature. Our tolerance is a little high on this right now, so I'm going to slowly reduce our tolerance. We're going to bring this down until we get more of what we're looking for. And now, with the tolerance down around 3, we can see we've selected all the triangles along the outer circumference of the tank here. So this is the tool that we want. Now that we've selected these triangles here, we can open up our cylinder tool. And because we're creating our cylinder based off of the triangle selection, we're creating a best fit cylinder that wraps around the perimeter of the tank here. We're going to adjust some of our parameters here. We're going to adjust the length of the tank. We're going to about triple it here. We're going to change that change about 400 here. And I'm just doing this so we've got excuse me, some visible material beyond the boundaries of the model here. So we'll go ahead, we'll create that cylinder. And now we don't actually want the cylinder for any of our flattening work, but we are going to use the cylinder to help us rotate and align the tank with the world axes here. So now that we have our cylinder, we can go ahead and we can use the align tool here, the align to origin, and we're just going to align all our mesh here. And what we're going to do is we're going to use a constraint entity. We're going to select our cylinder as our constraint, and we're going to constrain to the z-axis. So now we can see, there's our triad right there. We can see the tank has been rotated, so the axis of the cylinder is constrained so it is parallel to the z-axis of the world space here. So we're going to go ahead and we're going to click the align button and finish the alignment. So now our model is aligned, and it's going to be a lot easier for us to start working with this. We're going to be able to create clipping planes and trimming planes based off of the XY plane, the green and the red arrows here, and it's going to be a lot easier to trim this. And also when we start rotating this around working within a Rhino, it's going to be a lot easier to do that now that our model is aligned to the origin. So we can now turn off our entities. We don't need to see that now. We're going to leave it in the document just in case we need it again in the future. But for now, we don't actually need the entity, so we'll turn it off. We'll hide it from view, so we're not looking at it. So now what we can do is the order doesn't really matter. We can fill in the holes, or we can start trimming it first. I think probably what I'm going to do is I'm going to start by filling in holes, and once we fill in the holes, then we can start to defeature this and trim away the parts of the mesh that we don't need. So we've got quite a few holes here. We're going to use the fill holes tool to help us fill in these holes. This tool has 3 different modes that it can operate in. It's got hole mode. So with this mode, it's going to allow you to select a boundary loop, and it's going to basically close and eliminate that boundary loop. So when we look at this hole here, if I click on the boundary loop, it's going to basically fill in that entire hole and eliminate it. So it's a very useful tool for this kind of work. The next mode is partial mode, and this allows you to fill in a partial loop. So I'm trying to find a good example of what this would do, and I'm not sure I'm going to find one, but for larger holes like this, it may be beneficial to slowly fill it in segments. So for this one here, if I wanted to just fill in this portion down here that I'm circling with my mouse, I can do that using the partial mode. And what we do is you choose your curvature, whether it's low curvature or flat. This obviously has curvature to it, so we're going to choose low curvature. Our boundary layers is basically the number of rows of triangles surrounding the selection point that is going to be used to determine the curvature of the fill. So 2 or 3, whatever you decide is best. You can adjust that later on. And then when we're ready to use the tool, we start by first selecting a start point and an end point. So these define the end points of the partial fill. And now we have to pick a point on the interior to tell us which side we want to fill in. So you can either pick a point down here and fill in this section, or we can pick a point up here and fill in this entire hole here. We're going to pick this portion down here, and once I click this third point, the algorithm is going to fill that in for us. So this would be a good use case for the set rotation center, and now I can very easily orbit around. And then the third mode would be bridged mode. This particular model does not require bridged filling, but we'll just cover this anyways. It's similar to a partial fill, except that it will create a bridge or a strip of triangles between 2 boundaries. So just like with partial fill, we have to define segments that we're going to be filling based off of. So if I wanted to create a strip right through here, right through the middle, I might pick a start point there, an end point there, and this will be the midpoint of my first selection. Now I have to pick another side of the curve, so I'll pick these 2 as the end points, and this is the midpoint, and the algorithm is going to fill that in for us. But for most of these holes here, we're just going to use the hole filling mode. It's the quickest, it's all we really need to do, and it allows us to very easily, very quickly rebuild this model, all the missing data. So I'm just going to pan up a bit, and now I can continue to select my boundaries here and fill them in. I'm not going to worry about the holes on the brackets here. Eventually what I'm going to be doing is just trimming the brackets right off, and we're going to be leaving just holes here to identify where those brackets are. And essentially this surface is going to become the inner layer of the material for the cover. So we're not going to worry about the brackets, we're just going to trim those off later. But we do want to fill in all the holes around the perimeter of the tank. So we're done with the main body. We'll move, we're not going to worry about the spout up here because we're going to be trimming that off. And down here, we are going to fill some of these in because we want to recover some of this data for trimming. So I'm going to trim it just above the weld line down here. So maybe what I'm going to do is a partial fill, and we'll pick some points right there, and we'll partially fill like that. We'll do the same thing down here, partially fill that. And my goal here is just to make sure I have enough information to do the trim without losing too much. And I'll do a whole fill right there. We'll reset our rotation center just to make it easier to rotate around. I just want to have a closer look at this one here. So actually I'm going to do a bit more of a fill on this one here. We'll fill in like that. And that should be good. So now that I filled the holes, I can start trimming off the excess that we don't need. So to do this, we're going to use the cut mesh tool. So we'll start with the cut mesh tool. And what I can do is I can turn on these derivative entities, and I can just use the XY plane as a cutting tool. I can also adjust it by grabbing the axis here. I can move the plane up or down to adjust the intersection of where this is going to be trimmed. Now with this tool here, the default behavior is to split the mesh along the plane and then keep both sides of the mesh. But we can turn that off. We don't need the bottom here, so I'm going to turn that off. And now once that's turned off, whichever side of the plane the arrow is pointing towards, that's the part of the mesh that is going to be kept. So with the way this is set up, I'm going to be trimming off and discarding all this information down here, but all this information up here is going to be kept. So I'm going to adjust my view. I want to make sure I'm only trimming off what needs to be trimmed. And actually, because this is cover, I'm going to trim it to right about there. That way the cover covers as much material as possible. So I'm just rotating the camera around. I want to make sure I'm not intersecting a hole. And once I'm happy that I'm not intersecting a hole, I click the OK button, and the tool is going to trim and discard the bottom part of the mesh. We'll use the tool again. We'll trim off the top part now. So again, I will turn this on, choose my XY plane. This time, we're going to turn off keep both parts, but I'm also going to flip the normal. And now I can bring this up here a bit more. And fine tune where the trim is going to be made. So at this point, we've got the main portion of our tank here. We've got this section. Probably what we're going to do is we're just going to trim this out as well. There's a couple ways we can do that. I think probably what I will do is create a circle and trim the tank based off of a circle. So we can do that. And then we can trim these, the couple ways we can trim those. And we also need to defeature all these different labels, this noise, this distortion here. So we'll do the defeaturing first, and then we'll trim the rest. So for this here, probably the best method would be to use a freeform selection. And this just allows you to very easily freeform select the area that needs to be defeatured. And whenever we're doing defeature work, I like to grow my selection just a little bit. And the reason being is this tool, if it's selecting a triangle that has a face normal opposite to the selection, it's not going to be selected, but grow selection will allow you to include those triangles. So we just grow the selection once, and then we can defeature, and that's going to very quickly smooth out the selection. So we'll do this down here as well. Grow our selection, defeature. Grow our selection, defeature. Grow selection, defeature. Grow our selection and defeature. So this plate here, depending on your needs, you may need access to it. If that's the case, then you can cut this out and leave it as a hole. Or if you don't need access to it, then my recommendation would be to, just like all the other noise and distortion there, we'll select it and then we can defeature the hole. And because I got a little sloppy there, I'm just going to maybe grow my selection twice, and then I can defeature, and that will eliminate that patch for us. To simplify the pattern making process, if I were to include these, we would get a pattern from ExactFlat. However, it may complicate the pattern. So for the purpose of this, it may be easier to remove the weld lines. So for that reason, I'm going to also defeature the weld lines and remove those. So I'll grow the selection and defeature. And this might be a bit more of a time-consuming process, but it's going to allow us to much easier do a much better job flattening with ExactFlat. So we're not going to do it all in one step. We're going to do this in a couple different stages. So we will defeature that. Selection and defeature. Grow selection, defeature. And then we've got our last one over here for the top, so we'll select that. Grow selection, defeature. Excellent. So we can see we very quickly, very easily removed that. And we've got a little bit of an artifact right here, so we're just going to defeature this one small bit one more time, and now we can see it's gone. So it's very easy to remove those weld seams. We're just using the defeature to smooth that out. And now we're getting more of the profile of what we would normally do with our material. So we'll do the same thing down here. So just start selecting some triangles. We'll grow our selection and defeature. And we'll keep doing this around the model until we've removed all of these weld lines. We got a bit of distortion here, so we'll just, while we're here, while we're looking at it, we'll just clean that up as well. We'll defeature that. There we go. So now that's looking a lot smoother. We've removed a lot of those welding lines. So now when we create our pattern, we can create a much smoother pattern. So we could do the same up here if we really wanted to. And I'm not sure if it's really necessary, but if we wanted to do that, we could just select these like that, just to smooth out this seam right there. And row selection, and we'll defeature that, and that just smooths it out. It gets rid of the hard ridge that ExactFlat doesn't like, specifically the uniform, the adaptive remesher may try to preserve that and inflate the triangle vertex count. So if we can smooth that out using VX model, that is advantageous. It's going to reduce the processing time with of ExactFlat, and it's pretty simple, pretty quick thing to do with VX model. So it's worth it to take the extra time to do that. So there, we've removed that seam, and we're good to go. So looking at the bottom here, we probably don't want this harsh seam all the way up here. So maybe what I'm going to do is I'll retrim the mesh to the XY plane here, and we'll just bring that trimming point up a bit more to just right to the base of the flare, and we'll trim that off. So this time I forgot to uncheck keep both parts, so we'll select our bottom half here, right click, and now we can just delete this mesh because we don't want it. And we're left with our mesh. So we're going to turn our attention now to the top and the bottom. If we look at them kind of perpendicular, they look pretty good, but when we look at the actual opening, we still got some pretty rough boundaries here. So what we're going to do is we're going to use the Edit Boundary tool. This tool again has a couple different modes. We've got multiple, and what you can do is you can select your whole boundary here. We've got a preview, and what it tries to do is it tries to smooth out the boundary. There's a partial mode, which is similar to the partial cutting mode. So the multiple will treat the entire boundary, partial will treat only a single part of the boundary. But the third mode here is very useful mode. This allows you to fit an entity, best fit entity to that boundary. So we're going to use this mode here, best fit, with our circle. There's also rectangle, and there's also slot, and we're actually going to use this again, the slot, for the brackets here. We're going to trim out some of these triangles here, remove the brackets, and we're just going to leave a slot shaped hole there. So we'll use the slot a little bit later, but for now we're going to use the circle, and we're going to best fit a circle to this boundary right here. And what this does is if we click apply, it's going to help us edit and smooth out that boundary to be a circle. We'll do the same thing for the bottom one down here. We'll choose circle, and we can best fit a circle and smooth out that boundary. So now we've got a much nicer, cleaner looking boundary here. So now we'll move our attention to the brackets here. I'm just going to get a good side view here, and there's a couple of different ways we can do this. There, using similar curvature, we're able to select that there. So maybe what we'll do is, let's go ahead, we can delete those triangles, and we'll use the tool down here again to delete those triangles. So now we've created a floating island of this bracket. We'll go ahead, do the same thing over here. Delete those. And then lastly, that's a bit too much. We'll try again in a different spot. Too much. And we're just going to keep picking in different spots until we get something that we like. So that's looking a lot better there. We are missing a few triangles here, but that's okay. We can just flip over to our brush selection and we can add the missing triangles. So now we can use our connected selection method, and that's going to select everything except those two handles. We can invert our selection, and we can delete the handles. So now we'll go back to our Edit Boundary tool, Entities, and we're going to flip over to our Slot tool, and now we can fit a slot through that. So that's a very easy way to remove the handles, but mark the location of where they're supposed to go. So the last method that we're going to do here is these cutouts for these ones right here. So there's a number of different ways we can do that, and I think probably the easiest is we're just going to use a freeform selection method. I'm going to select triangles along the edge here. And I'm just going to grow my selection, and I can delete those triangles. We'll do the same thing for this plug over here. I'm just going to use my freeform selection. And I can grow my selection and delete those triangles. Once again, we will select connected here, and now we can invert our selection, and we can delete the floating triangles there. And now we can once again edit our boundary. We're going to go back to entity mode, circle, and we can just best fit a circle to that entity. And we'll do the same thing for this one over here. Edit boundary, entity, circle, and now we can best fit a circle through there. So at this point, our tank has been split. So or sorry, not split, but it's been cleaned. So now what we can do is we can start to split our tank. So I think what we're going to do is we're going to create some points first. So we know that the center of our plane is always going to be the axis here. So we're going to create a few points here just to give us some reference points. So we'll call this one point 1, and we're going to create it based off of numerical values. X, Y, Z will be 0, 0, 0. So now we've got our first point right there. We'll create another point. We're going to change our Z value to about 400. So this is going to place the second point right up there. Actually, we'll make it about 500 just so we can very easily see it. Now we're at 500 right there. And we'll create and close that. Now we're going to create two reference points. We're going to create one based off of vertex selection, and we're going to place it right here. So this is going to be our first reference selection, and the second one is going to be right here. These are where we want our planes to intersect the mesh. So now what we can do, actually, zoom in. My apologies, forgot to hit the create button. Zoom in, create a point right there, create. There we go. So now we've got our different points. We've got points 1, 2, 3, and 4. So now what we can do is we can go to our cut tool. And actually this is going to want us to pick either a plane or entity. So we're going to create planes first. So we'll create a plane based off of point selection, and we're going to create a plane based off of points 1, 2, and 3. Now we can see our plane right there. So we'll create that plane, and we're going to create another plane based off of points 1, 2, and 4. So we'll create that plane as well. So with our different planes there, we can now go ahead and cut the mesh. Create it based off of plane 1. Now we've got our different cuts right there for 2 halves. And now we can cut the remaining mesh, this one here, based off of the second plane. Actually, this one here that we want to cut. So we'll cut this one based off of Okay, so what we want to do is send that entity over there. Now we can cut this mesh based off of plane 2. There we go. So now we have our 3 pieces. So for this particular model, we can do the splitting either in VX model, and for this particular model, because we're not drawing splines on the surface, it's not necessarily easier or harder to do the splitting in VX model. We can also split it in Rhino based off of planes very similar to what we've been doing here already. And in fact, we're going to create a few more splits on these meshes here. And we're just going to separate the top from the bottom as well. That way the sides here can be a single piece, and then the bottom down here can be a single piece of fabric. So we're going to go ahead, we're going to do that as well. We're just going to use and unfortunately we can't select them there, but one thing we could do would be to combine the meshes, but we're going to save that for, actually we'll do that right now. We're going to combine all 3 of these meshes into one mesh. There we go, combined. So this is very similar to in Rhino to simply joining our mesh together. We can now explode this in Rhino, but we're going to join it together now, and we're going to once again use our cut mesh tool, and we're going to basically just split it based off of the XY plane. So we're going to drag this to, I'm just looking at the intersection point, and I think somewhere right along there, we're going to try and get somewhere along the midpoint of the radius. That way we're trying to balance the strain along the seam. So we'll go ahead, we'll split it once there, and then we'll split it once more using this tool up here. X, Y. This one will flip the normal. There we go. And we can split it just like that. And then once again, we'll combine these 3 meshes here. And we can see the 3 meshes being combined. So we'll go ahead, we'll combine those. And at that point, we've successfully cleaned our mesh, we've trimmed away the unneeded data, and we've split it up. So we started off with scan data that looked fairly noisy, and what we did is, first of all, we oriented our mesh. So we created a cylinder using the cylinder tool based off of the triangles of the main body. So we created a best fit cylinder around the mesh. That then allowed us to use the alignment tool, align to origin, to rotate and translate the mesh. So the mesh was aligned with the orange ring. We used the rotational axis of the cylinder as a reference marking, and we reoriented it so the axis of the cylinder was parallel to the z-axis. Next, we used the cut mesh tool to create a couple planes. We cut off the top and the bottom of the mesh. We then used the hole filling tools, the fill holes tool, to fill in all the holes. We used a combination of the hole method as well as the partial method. And I showed you how to use the bridge, although that's not necessarily required for this model. Once the holes were filled, we defeatured a lot of the mesh. So we used the defeature tool to remove the weld seams. We used it to remove the labeling, the tin plates, all that kind of stuff. And then once those were gone, we then trimmed away the plugs here, drain plugs, whatever they are, as well as the brackets. We removed those, and then finally we used the edit boundary tool to smooth out the boundary. So we used the entity mode and interpolated or created a best fit circle for the top, bottom, and drain plugs, and we best fit a slot for the brackets here. So what we're left with is basically the skin of the tank that needs to be covered and wrapped for our insulation blankets. So once we did that, we used again our cut mesh tool to cut up the mesh. We created a cut using a plane that intersects the z-axis and a point right here. We also created a plane that intersects the z-axis and a point right here and split the mesh based off of that. And then we split the top and the bottom. We combined all of those results into a single mesh. That's combined 2 down here. So what we're going to do now is we're going to export combined 2. And this is going to allow us to create an OBJ file, which we can then load into Rhino and ultimately ExactFlat. So we're going to select Combine 2. We're going to, actually first we're going to save our model. We're going to save our session. So we'll just put this on our desktop. And we'll call this gas tank clean. That way we can come back and continue our session at a later date. So now we can go to File, Export Mesh, and it's very important down here we want to choose the correct file type. We want to select Wavefront OBJ, so we'll select Wavefront OBJ, and now we can save the file. So again, we'll just call this gas tank clean.obj, and VX model is going to export that data to a new mesh for us.
This concludes part 2 on how to convert your scan to 3D CAD. In the next section, we'll cover how to flatten from 3D to 2D. It's part of our video series on how to triple your pattern making in 3 easy steps using ExactFlat Scan-to-Pattern. It's the faster, better, cheaper, and easier way to create patterns for all your products. Be sure to check out our other videos, and you can also contact us at your convenience for a demo or to learn more. We'll show you how.